So this is a tutorial to guide you on how to get started on assignment 3, which is basic lighting and shading. So in assignment 2 you made your wireframe model, which looks something like this, and now what we're going to do is that we're going to fill in the sides and give them color and also apply some basic shading. The kind of shading that we're going to do is per surface shading. So you notice here that each of our polygons is made up of a bunch of triangles, and each triangle has a uniform color. Later on we'll talk about smooth shading where it looks like more of a gradient, but for now this is all we're going to have to do. To do this, we have to set up a couple things in our JavaScript and shader code, but I do that for you in this example. Most of this stuff is the same from assignment 2 as in the starter code I gave you for assignment 2, except that now our init attributes function does a little bit more. If we go over there, we notice that we still assign the A position buffer like before, which allows us to pass the position of each vertex, but we also enable a color, which allows us to set the color of each vertex individually, and we'll see how to do that in a little bit. In the shaders, this translates to having this A color attribute in our vertex shader, also this varying vec for V color, and in our main function calling V color equals A color. Then in our fragment shader, we also have varying vec for V color, and we set GL color frag color equal to V color. Essentially what's happening is that from JavaScript we pass in the A color, which is the color of the point. The vertex shader passes that A color to V color, which is the color of a pixel, that then the fragment shader figures out how to shade correctly. For now, it just passes it directly. So if you have this set up, you should be able to pass colors pretty easily. Then we also have 3 function calls to draw our 3 different polygons. First we draw the wireframe, and it's red. We also draw 2 filled versions with 2 different methods that I'll go over, and they're green and blue, like you can see here. Okay, let's first look at the polygon drawing code. This should look pretty familiar to what you did for assignment 2. I have this function that takes in the GL drawing context. We also have the number of sides n, the radius of our polygon, the 2 center points, or the 2 center coordinates rather, and the RGBA coordinates of the base color. Again, after we apply shading, that color might change, but this is kind of, you can think of the material property, or what the color of the object actually is. Then of course we have our vertex array, our index array. We also have to calculate some angles for getting that nice round curve, or polygon. Do some calculations to calculate the points of the triangle. In this case, we have the center point, which is given to us, but we also have to calculate the 2 outer points, namely, if I'm thinking about this triangle, this point, and this point. And then, I'll skip over the coloring part for now. We simply push in the center point with the 4 color coordinates, push in the first outer point with the 4 color coordinates, and push in the next one. Then, like before, we have to push into our indices array the connections. So we start at the center index, go to the first outer one, then the second one, then go back to the center to wrap around. And that's just drawing this triangle. And then of course we set the buffers and draw with the line strip argument. Right? So I'll go over this in a little bit, but here you'll notice that this loop is essentially making each separate triangle. See, each loop iteration we draw a single triangle, or we create a single triangle. So within each loop iteration we have to calculate what the color will be for that surface. And this is the code that does that, and we'll talk about that in a little bit. Okay. Next, we have draw polygon triangles. So now if we want to draw our polygon filled in, we're going to have to use a different drawing mode, namely triangles. However, you'll notice that the code is hardly different. All the preparation stuff is essentially the same. This color code will also be the same. We're pushing in the same vertices, right? We still have these 3 points on a triangle. The only difference is that you notice that we don't have to wrap around for the index connections. Here we have to push in the center point again, but here we don't actually have to do that. Because when we call draw elements, we use the drawing mode GL triangles, and that automatically assumes that each pair or each triplet of indices is going to be one triangle. So it's essentially the same, and then we get that nice filled in color. We also have one other way of drawing solid triangles, and this is the blue one, I believe. But let's check. Yes. So draw polygon triangles 2 draws the blue one, which is the same, it's functionally the same, except that it uses a different way of drawing. All these calculations you'll see are the same. Except you notice we don't push in any indices. In fact, we don't have an index array at all. And the reason for that is that we use instead the old draw arrays function. The draw arrays function, what it will do is that it will look through the vertex array and assume that each triplet of 3 vertices, sequentially in order, is going to be a triangle. So this is another way of drawing your triangles if you so wish. We're not going to grade against which drawing mode you use, as long as you get something that looks something like this, except on your cylinders. Now let's look at this faux shading. So we want each surface to have a different color. So if we say look at draw polygon triangles 1, this loop goes through each surface, and we do this light calculation here. This is just an example. This surface shading is actually kind of a hack. It's not true shading, because all I actually do is that I make it so that the farther right you are, the darker you are. You're going to have to do something a little bit more sophisticated. So what we do here is I just calculate the color. Var color equals shade transparent. I pass it the averages of the points. Essentially what that says is find the center point of this triangle for our lighting calculation, since again each surface has to have the same color, so each of these 3 vertices on the surface has to have the same color. And so what I do is I pass in the average. You're not actually going to do this, but I do that for now, and I also pass in the original RGBA values. Because again, the apparent color of our shape is going to depend on both the lighting, the light source, and the actual material color of the object. So let's look at shade transparent. It's a very simple function. All it does is that it takes in the XY point of the center of the triangle and also the original RGBA values, and just multiplies them by a ratio that goes down as you go to the right. So we just change the color by that ratio. And then we get this nice shading right here. And so that's how you can actually edit the color of each vertex, by pushing in a different color for each point. You'll notice also that this is pretty verbose, even though it doesn't really have to be, because the way the vertex array works is that all the coordinates have to be stacked up on top of each other. Here we have the X position, the Y position, the Z position, which is 0 in this case, but won't be 0 in general for your cylinders, and also the 4 color components. You might want to make a function that kind of does this in a somewhat nicer way, but that's up to you. Your shading function is not going to use the position as so much as actually going to use something called the normal, which we'll talk about or may have already talked about in class. So that's the starter code. Hopefully this will be able to get you started up pretty well. Again, you'll probably not want to actually use this as starter code. You'll probably want to build off of your previous one. Just note the ways in which we took our wireframe points, transformed them into triangles, and how we actually apply the lighting. Alright, good luck.